Hi everyone, and welcome back to this series of short videos about CytoPipeline, an R tool for building and visualizing pre-processing pipelines for flow cytometry data. In the current video, we're going to run the pipeline we've built up in the previous videos, and we'll discover the link between a run and the CytoPipeline cache which is stored on the disk. So let's get started. And so let's go back into our code, where in the previous video we have created our CytoPipeline object based on the JSON file input, which is specified here. Okay, and again, let's recall that by using the plot CytoPipeline processing queue function, we have obtained this workflow where basically all the steps are described and those bubbles are orange, because basically for the sample file that we specified, the first sample file, there is no results yet that is available on the disk. Okay, so let's execute our pipeline, and before doing that, let's tweak a little bit our JSON file in order to introduce a small bug into it. So this JSON file describes all the steps one after the other, and let's imagine that as a user we are wrong because we replace this parameter nclust by nclusters. It's a voluntary mistake here. So because the remove debris flow class tmix function needs not nclusters but nclust parameter. So this is a bug. Okay, so let's save the JSON file and recreate the CytoPipeline object to take into account our changes. And so let's see what happens when we execute the pipeline. We do this by calling this execute function. The first parameter of the function is the CytoPipeline object itself. And the second one here is the path, so the path to the directory where we will store all the results. And so this result directory for the time being is completely empty. All right, so let's now run our pipeline, execute, and what happens? So this launches the pipeline, and so all the steps are run one after the other, starting with the scale transformation processing queue. There is only one step there. Then moving to the pre-processing queue for the first file, because this pre-processing queue is run one file after the other. And so we can see that we have proceeded with step 1, which is reading the flow frame of the disk, then proceeding with step 2, removing margins on this file, then the remove doublet steps, which runs fine, and then proceeding with remove debris. There, as expected, we get an error saying that the parameter nclust is missing, which is of course no surprise. But let's see what happens when we now call the plot CytoPipeline processing queue function again, displaying the workflow with the first sample file. Then we can see that now the first 3 steps related to this first sample file has run correctly, because they are now mentioned in green here. Okay, so this is an interesting part. Now I suggest we go back to our JSON file and put here the correct parameter, so nclust instead of nclusters. Save the JSON file again, recreate our object, so using the CytoPipeline constructor, and execute again our pipeline. And so when we do this, one interesting thing is that all the steps that have run previously without any issue are not run again, and this is mentioned here, found in cache, meaning that all those steps we already have the results that is stored on the disk cache. And where is this disk cache? In fact, it is stored in the results directory. So let's move to the results directory and see what is now in this directory. So we have created here a subdirectory which is hbvtdemo, and this has been done automatically by the execute function. And we can see that in this directory we have one output directory and a cache directory. So basically this is where we store all the intermediate results using a mechanism that is implemented by the bioconductor package, which is called BioC file cache. So BioC file cache using a SQLite database, and all the files corresponding to different intermediate results are stored in files where the name here is a bit, let's say, not human readable, but everything is stored there, and we will be able to take advantage of this for the display of the results. All right. So now we should have all the output here, so meaning that the two files that have been pre-processed are now available as FCS files. So this is the output of the whole process. Okay, so let's now go back again to our code. And so we can see here in the console that all the different tests have been run without any issue, including the PicoQC call for the first file, and then moving to the second file, all the tests have been run. And so now if we run again the plot CytoPipeline processing queue, then everything has turned on green. And that's it. In this video, we've learned a few interesting things about running our pipelines and the interesting link between a run and the disk cache. In the next video, we're going to visualize our results.